Hey guys, welcome to Master and Learn It. In this video, I'm gonna show you how to prove the compound angle of cos A minus B equals to cos A dot cos B times plus sine A dot sine B. So before we can prove this, there's a prerequisite. These are the things you should be able to know by now. So I'm not going to explain them, but if you want to know, you can check one of my videos on how to explain them. But before we can prove this formula, you should be able to be acquainted on trigonometric ratio that sine theta can be written as y, because we know that sine is opposite over hypotenuse, the opposite being y, the hypotenuse being 1. So sine theta can be written as y and cos theta can be written as x. So this is something you should be able to do by now. You should also be able to know how to do the cosine rule, which you have learned in the previous grade, which says a squared equals to b squared plus c squared minus 2bc cos a, of which a, b, c are the sides of a non-right-angled triangle. You should also be able to use the distance formula. That means if you have 2 points A and B and you want to calculate the distance between them, you say the x-coordinated A minus the x-coordinated B squared plus the y-coordinated A minus the y-coordinated B. Then this is the distance formula. And you should also know the square identity. That means sine squared theta plus cos squared theta equals to 1. That means sine squared A times cos squared A is still equals to 1. So once you know this one, we can be ready to begin our video. So how do we start this video? We're going to start this video by drawing two angles. Remember, we have an angle of A and we have an angle of B. So I'm going to draw two of these angles in this part of the circle that I have. So remember that we're dealing with a unit circle. This is something you should understand at this point. A unit circle is just a circle with a radius of 1. That means if I write from the origin all the way to the circumference there, the radius is going to be equals to 1. So everything we're proving here is based on the unit circle, a circle of a radius of 1. So that's the first step. So let us start creating our small angle B. So I am going to say, remember, this is another thing you should know, that if we measure an angle anti-clockwise, we regard it as positive. So that means all angles are measured from here. So if we just go anti-clockwise, that's a positive angle. But if you go down or clockwise, that's a negative angle. So if you see an angle that is negative, it means it was measured clockwise. But if you see an angle that is positive, it was measured anti-clockwise. So now I'm going to start by drawing my angle A and my angle B. So let me start by constructing angle B rather. So I do have my first point. So understand that this negative is not for B. This doesn't mean this angle is a negative B. This means it's cos A minus cos B. So this B is positive. So I'm still going to measure it anti-clockwise, because if it was a negative one, I should have measured it going down. So you should be able to know that this can be written like this. This angle B is a positive, right? So with that in mind, we can start doing that. So I'm going to create an angle of B from the positive x-axis anti-clockwise. So I've created an angle right here that I'm going to call angle B. So I've measured it anti-clockwise. And I want to create an angle of A as well. So I'm going to measure it from the positive x-axis anti-clockwise, and let me end there. So I've created also an angle to that point. So I've created, so my angle A starts from here all the way up to here. So that's my angle A. So what is the angle between this? If the whole of A is this one and B is part of A, so what is this part? We're gonna say the whole of angle A minus B, right? So the angle that's in between is all of A minus B. Having done that, now I have created my radius. Remember, this is a unit circle, so my radius has a length of 1. I'm going to use a red marker, so that is a radius of 1. And also this is my radius, so that's also equal to 1. So this looks like a triangle with two sides and an angle, but we all know that triangles have 3 sides. So let's connect the other part to make our triangle complete, isn't it? So I'm going to connect these points to make it a complete triangle, though I'm not really good at drawing and at accuracy there, but you can be able to see that, yeah, this is the other line that makes this to be a triangle. So now we can name these points to say, let me call this point P. It's fine, I can call it point P. And let me name this point to be point Q, which is my point Q. So remember, every point has an x coordinate and a y coordinate, x coordinate and y coordinate. So now we have a problem right now. Our triangle is almost complete, because remember, a triangle should have 3 sides, and we do have 3 sides right there, 1, 2, 3. And a triangle should have an angle, and we do have the angle here, and the length of one of the side is 1, the length of the other side is 1, but we don't know the length of this one. So what should we do? The first thing, let us put the coordinates there. So remember, we're dealing with trigonometry here. So I'm going to substitute x and y with sine and cosine. Remember, if you still remember from the trigonometric ratio, that sine theta can be written as y. So, and cos theta can be written as x. So wherever there's x, I'm gonna put cos of that angle. So wherever there's x, I put, so this is gonna be cos of which angle? This is the smaller angle B that made this one. So this is B. And sine, wherever there's y, we put sine. So this is gonna be sine of that angle, which is sine, sorry, this is sine A, this is sine B. We're talking about this angle that made this. So this is sine B, this is cos B, and we have sine B. So at this point now, this point is created by the angle A. So we now know that x means cos, isn't it, on a unit circle. So we have cos, and it was created by angle A, and y means sine and was created by angle A. That's pretty simple, isn't it? So we have 2 things on our disposal, 2 things that we can manipulate to get the distance of these 2 points. That's where the distance formula comes into play, as well as the cosine rule. Because remember, a cosine rule helps us to calculate the length of the side of a triangle, and the distance formula also helps us to calculate the length of the side of that triangle. So I'm gonna start by applying the cosine rule. So the cosine rule says, if you need one of the sides, which is A, so I'm gonna write the cosine rule right here. So using the cosine rule, alright, I'm gonna write it here. So the cosine rule said a squared, being any side that you are looking for, equals to the other side squared plus the other side squared minus 2 times these sides b, c, cos of a. So in this regard, a squared just represents the side that I want, and I'm just going to call it d, isn't it? Just to represent distance. So instead of calling it a, I'm going to say distance squared equals to one of the side, this is one of the side, and the other side. So this is 1 and this is 1. That's the length, isn't it? So that's 1 squared plus 1 squared minus 2 times 1 cos of the angle. So this side, the cos of that angle is cos A minus B. Then we simplify as to the distance of this line is 1 squared is 1, 1 squared is 1. So 1 plus 1 we get 2 minus 2 times 1 remains 2 cos of A minus B. So I have expressed this distance PQ, which I just chose to write d squared. This distance of PQ using the cosine rule. So this is the meaning of this side using the cosine rule. So that's the value that I have. So now I want to also express this side using the distance formula. So we all know that the distance formula is just right here. If you have point A and B, in this case my point is P and Q. So point PQ squared equals to, open bracket, the x coordinates at P. So the x coordinates at P, the x means cos. So the x coordinate, which is cos A, minus the x coordinate at minus the x coordinate at q. So minus the x coordinate at q. Or let me just write it first in this way so that maybe you can get the idea of what's really happening. So let us just say pq squared is the x coordinate at p minus the x coordinate at q close squared plus the y coordinate at p minus the y coordinate at q close squared. So now we know that pq squared just represents this distance, and I'm just gonna use d squared equals to the x coordinate at p. Now instead of writing x, we write cos a minus the x coordinate at q. The x coordinate means cos b, and everything is squared, plus the y coordinate at p, so y means sine, so we have sine a minus the y coordinate at q. The y coordinate at q is sine b close squared. Then let us just clear this bracket, so this simplifies to, these are two terms, so you square this one, we get cos squared a. This is just the knowledge. You should be able to know how to clear brackets, but if you don't know, just go and check one of my videos on clearing brackets like this. So we get negative 2, because I'm going to multiply this 2 times, it's going to be negative 2 cos a times cos b. Then we square the last one, that's going to be positive cos b squared. Then I do the same right there, so I'm going to get positive sine squared a. Then I do that 2 times, it's going to be negative 2 sine a dot sine b. Then I'm going to square the last one, which is positive sine b squared. Then from this point now, we still remember that there's some sine squared, cos squared there, and that's where the square identity comes. So sine of a certain angle plus cos of the certain angle squared, they equal to 1. So that means I'm going to circle these things in red. So we have sine squared a plus we have cos squared a. So these ones, when we add them, they give us 1. So I'm going to write it in red so that you know where it's coming from. And then plus, we also have this, I'm going to circle it in blue. Sine squared b right here plus cos squared b. That's the square identity and equals to 1. So I just wrote them in red. Then we realize that we are left with these two terms, which is the other one is this one, which is negative 2 cos a times cos b. Then the other one, which is I'm going to write in a different color, just negative 2 sine a dot sine b. And we can notice that this is cos A, cos B. This is sine A, sine B. So they are not like terms, they are not the same, but they all have the common factor negative 2. So I'm going to add these ones. 1 plus 1, we get 2. Then these ones, there is a highest common factor, which is negative 2. We divide negative 2 into that, we get positive. Let me continue in red, which is positive cos A dot cos B. Then a negative and a positive, we get positive sine A dot sine B. Right, so now I have expressed the distance PQ using the distance formula. So this is the value that I now have. So this is the value of the side PQ using the distance formula. And this is the value of PQ using the cosine rule. So what do we call these ones? These magnitudes are the same. These things are exactly the same because we proved the same distance using another method, which is the cosine rule, and another method, which is the distance formula. So we call them identities. These two things are identities. So we can equate identities, simplify them. So how do we simplify identities? I'm not sure of my space right there. If you can be able to see me, I'm gonna try to write it, but if you don't see it, I'm gonna erase the other part so that you can see. So we're gonna equate these two identity. So the first identity, the distance PQ in terms of the cos is gonna be written as cos, or it's gonna be written as so the distance PQ in terms of cos is this one, is going to be written as 2 minus 2, that's what I'm writing here, cos A minus B, isn't it? That's what we have proved, right? Then is also identical to, or is also equal to, you could write 3 lines for an identity or 2 lines for equal to. So I'm going to use 3 lines to emphasize that these are identities. Is also equal to this that I have on this side. So I'm going to write it in a different color, which is equals to 2 minus 2 cos A times cos B plus sine A times sine B. Then, when we have two identities, we can simplify both sides. So there's no need of taking the other thing to the other side because the identity is not going to be the same. So what problems do I have that I need to clear up a little bit? I see that right here I have a 2 and there's a 2 there. So if I want to get rid, let me subtract both sides. 2 minus this 2, and I can introduce a 2 minus this 2. I want to simplify my identity. I just want to simplify as far or as further as I can. So 2 minus 2 there, that's 0. So I'm left with, I can write this in red, negative 2 cos, open bracket, A minus B. Then is identical to, then that side I've already subtracted 2 minus 2, that's 0. I'm left with negative 2 cos A times cos B plus sine A times sine B. Then what's the last? I have a coefficient and a coefficient there. Let's divide both sides by the coefficient. So dividing by negative 2 and dividing the side by negative 2. Negative 2 cancels with negative 2 and I'm left with cos. So I'm left with cos, open bracket, I'm just going to write in a different color to show that our angle A minus B is equal to or is identical to, and now negative 2 cancels with negative 2, then I'm going to write it in different colors. So we now have cos A times cos B plus sine A times sine B. And there we go. Cos A minus B equals to cos A times cos B plus sine A times sine B, and that's exactly what we have. Cos A minus B equals to cos A times cos B plus sine A times sine B. So this is how we prove the compound angle formula. So we simply said compound angle formula means we're adding two angles that are different, but there are also some other double angles, some other compound angles that we are going to prove in the following video. So watch the next video. Thank you.